This is an associated research demonstration for Intertech Labs on the Omnia 2, and I'll also give you a brief look at the AutoWare 2 software. The screen you're looking at right now is actually the AutoWare software that I used to put information into the unit, as well as what I'm going to be used to track data for the test sequences. The goal here is to get a feel for the test time with the parameters that I was given by Intertech Labs, and to show you how easy it is to set up and give you a feel for how long it takes to run an entire sequence from start to finish. Before we get started, I'm just going to show a brief series of connections here. This is the back of the Omnia unit, and what you see actually is I have line, neutral, and ground connectors which go out to this universal adapter box. What I also have is a return or case lead, which is going to go to the chassis point of the device under test. The purpose of all of this is to be able to make one series of connections for all your test types. When it runs the high pot test, it actually shorts relays internally to short the mains and return on the grounding point with this case lead. Then for the ground bond test, it'll actually inject current here and return on the case lead as well. And then of course there's an internal power source, since this is the 8207 built into the unit, that I'll actually be using to power up the DUT. Now the DUT that I'm using here is just a very simple small fan device. The reason I'm using a fan is when we start going through the run tests, you can actually see that it's on, and you'll also notice I have the DUT in the on position. So with the parameters that I was given by Dave, I was able to set up a sequence of tests, and we'll get this going. What I'm going to do is set up the unit and then push the test button, but simultaneously start a stopwatch online to give you guys a feel from start to finish on how long this is going to take. I'm actually going to start the stopwatch now, so just keep in mind I'm adding a couple seconds by starting it now, because then I'm going to have to go over, connect the DUT, and initiate the test. So I will begin now. So all I need to do is take the plug in my DUT. I'm going to go ahead and crimp the chassis point right here. And now I'm going to set the camera over here so that I can initiate the test from the front panel. So you can see we've begun the sequence. Now I'm starting with the insulation resistance test per my conversation with Dave, and you're going to see it run through the whole gamut of tests. After the timing demonstration, I'm going to give you an example of how you set these tests up via the front panel. I'm just going to do that to give you a feel for how all of this is going to work. So stick around after the test sequence has completed so that you can see the test parameters that I actually used, as well as the different features on the unit. Now is the ground bond test, which we spec'd in at 120-second test. Here you can see the current, the resistance I'm getting on the product, as well as the current testing time. It also gives you an indicator here as to what test I'm running and what sequence that I'm in. But you can see we already run the insulation resistance test, and everything shows up green to indicate a pass, and now we're on the ground bond test. Next will be the AC high pot and then the DC high pot. Alright, now we're in the ramp-up cycle of the AC high pot test. We've spec'd in a 10-second ramp-up, 10-second dwell, 10-second ramp down. Oh, pardon me. Actually, a 60-second dwell time per the standards, not a 10-second dwell time as I just mentioned. Now we're in the ramp down phase. You can see the voltage and the leakage current dropping. Now we go into the DC withstand test, also a 10-second ramp up, 60-second dwell, 10-second ramp down. This will be followed by an 8-step line leakage series, and the parameters I was given were at 120 volts per the 60950 measuring device. And we didn't specify a time on this, so I only have about a couple seconds per each condition. I do have it on continuous run, which means that the product is not going to power down in between line leakage steps. So we're actually going to run all earth leakage tests right in a row with all fault conditions for a total of 8 tests, which you'll see here. So here we go with the line leakage series. You can see up here it's going to cycle through the various fault conditions. Now we're on the DC continuity test, and we have almost no resistance in the line. Now the functional run test. I'm running the first one at 132 volts for a 10-second dwell time, the second one at 108 volts. I can actually hear the fan coming on now, and it's running a little high, and now that it dropped to 108 volts, it's running just a little bit lower. I'm actually going to stop the sequence now because I can see that it completed, and on my end I can also see that the data file has also completed.